Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve problem number 39 of GATE 2022 statistics paper. The problem says that X is a random vector of order 3. It follows normal mu sigma, where mu is 2 minus 3 2 and sigma is a covariance matrix of X, and A belongs to real number. So given that the partial correlation coefficient between x2 and x3, keeping x1 is fixed, is 5/7. So we need to find the value of alpha or A. So value of A. We need to find value of A. So to find value of A, we need to find the correlation matrix, which can be obtained by the formula. This is the transformation. So the variances of x1, x2, and x3 are 4, 2, and 2 respectively. Now the correlation matrix can be obtained from the formula equal to R. R is the correlation matrix, and sigma is the variance covariance matrix, and D is the diagonal matrix consisting of the diagonals of standard deviations of random variables x1, x2, and x3. So R can be obtained by D inverse transpose into sigma into D inverse. So D inverse is basically diagonal matrix with diagonal elements half, 1 by root 2, and 1 by root 2. This can be found from the D matrix. You can check, the inverse is this. So the correlation matrix is obtained as the diagonal elements are 1, and these elements are minus 1 by root 2, 1 by root 2, and A by 2, and this is symmetric matrix. So accordingly the other elements will be placed. Now R can be written as R11, which is 1, then R12, correlation between x1 and x2. This is the correlation between x2 and x3. This is again 2 1, correlation between x2 and x1. They both are same. Now this is R22, which is also again 1, and this is R23. Sorry, this will be R13. Now this is R31, same as R13. This is R32, same as R23, and this is R33 equal to 1 again. So from this we get R12 is minus 1 by root 2, R13 is 1 by root 2, and R23 is A by 2. When we have the partial correlation coefficient between x2 and x3, given x1 fixed. So the partial correlation coefficient is given by the formula R23.1. This is the symbol. R23.1 is the partial correlation coefficient of x2 and x3 given x1 fixed. So this formula is given by R23 minus R12 into R13 divided by 1 by R square 1 2 into root over of 1 by R square 1 3. So we have the values of R23, R12, R13. Putting the values, we get A by 2, R23 is basically A by 2, and R12 is minus 1 by root 2, and R13 is 1 by root 2. So they both multiplied equal to plus 1 by 8. And in the denominator, we have 1 minus R square 1 2, which is 1 minus 1 by 8. They both are the same, so we get 1 minus 1 by 8 into denominator. So we have the given formula, given value of R23.1 is 5/7. So equating those two values, we get A by 2 plus 1 by 8 into divided by 7 by 8 basically. So this comes into 8/7 equal to 5/7. From this we get A by 2 equal to half. You can check, and we get A equal to 1. So we need to find the value of A. So it is coming out to be 1. Hence option A is correct. We get from our problem that option A is correct. So the motivation of the problem is to find the correlation coefficient between the variables x1, x2, x2, x3, and x1, 3, which can be found by this formula. You can derive this formula also. You can try yourself. It is easy. So by this transformation, we can obtain the correlation matrix, and from that we can get the correlation coefficients of different variables, and from that we get the partial correlation coefficient, and hence the problem is solved. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay tuned and stay blessed.